my name is Kuzaira Kimi, and today I will talk about what is differentiation. In mathematics, differentiation is basically the process of finding the derivative, which tells us the instantaneous rate of change as a dependent variable with respect to an independent variable. Graphically, it just means finding the exact gradient or slope of the tangent line to a curve at any specific point. And now I will tell you about the technique of differentiation. First, the product rule. Second, the quotient rule. And last but not least, the chain rule. First of all, we will go to the product rule. We use this technique when we need to differentiate a function that is made up of two or more terms multiplied together. Instead of trying to expand everything first, which can get really messy, we use the formula f prime x equal to uv prime plus u prime v. By keeping one term constant while differentiate the other and then swapping them. Second, the quotient rule. This is the technique we use when a function is written as a fraction, where one function is divided by another. The formula is fx prime equal to vu prime minus uv prime over v square. We have to be really careful with the order of the term in the numerator here because of the minus sign. And we always divided the whole thing by the original denominator square. Last but not least, the chain rule. We use this rule when we are dealing with composite function, which is basically a function inside another function. It works by introducing an intermediate variable to differentiate the outside function first. And when multiplying it by the derivative of the inside function, following the formula dy over dx equal to dy over du multiplied by du over dx. That's all from me, and now I will pass this to my friend.
Question 2. Differentiate the following function with respect to x. Question A. We use product rule. Why we use product rule? Because there are more than one function in this question, which is first function and second function. We find our u prime, v, and v prime, and then we substitute all of this into our formula. After we substitute the formula, we will gain this one, and after that, we can simplify it by factorize negative 5x squared exponent cos x, and you will get this as a result. Question B. In this question, we differentiate it like usual. We differentiate ln, and then we differentiate this fraction. And I notice this is a fraction, so we have no other choice to use quotient rule. And then we will got this. So in the quotient rule, we find our u prime, v, and v prime. So, and I notice we can bring the fraction below to the up. So you will get this. And then after you find the u prime, v prime, you substitute it into the formula. You will get this. And we can simplify. After that, we can simplify it. We remove one sign to x and one more sign to x from here. Remember, it has two signs to x over here. So we can remove one. And this one, we can multiply it just like usual. You will get this. And after that, we separate it and we will get this. And then we can cancel out here and here to simplify it. and what will remain here is x. And over here, we will just divide it like usual by simplifying it. And we will get this. And by using identity trigonometry, we can simplify it to this one.
So right now, we are going to talk about implicit differentiation. Now, implicit differentiation only can be used when it's difficult for us to isolate the variable y. Yes, y. Now, for the first step, we have to differentiate the equation. Second step, we must use the product rule or quotient rule if there is any. Now, for this question, we have y sin to x. Now, in this expression, there are two factors, which is y and sin to x. Now, that tells us to use product rule. For the third step, we have to differentiate the y. Now, when we differentiate y, the derivative for y is always going to be dy dx. Now, for the last step, we just simply isolate the dy dx. Now, at the end of your answer, you should get dy dx over something something. Now, as you guys can see, I already differentiate the expression y sin to x. And as you guys can see, our u is y u prime dy over dx, v sin to x, and our p prime is 2 cos 2x. Now, when we apply all of those into the formula of the product rule, we'll get the answer in the green box, which is 2y cos 2x plus sin 2x dy over dx. Now, after we finish differentiate the current expression using the product rule, all we need to do is just simply differentiate other expression available. Now, for the loan to y, when I differentiate it, I get 1 over 2y multiplied by 2 dy dx. Don't forget to differentiate the y. That's why we get dy dx equal to 4x plus 0. Now, as you guys can see in the black box, we can factorize the dy over dx because it's a common factor for those two expressions. And we should get dy dx sin 2x over 1 over y equal to 4x. Now, the final answer should be dy over dx equal to 4x minus 2y cos 2x over sin 2x minus 1 over y. That's all for me today. Thank you.
For question 4, we can apply this formula to solve the equation. Firstly, we let fx from the question. Then the answer we get from that fx from equation is the fourth root of x minus 2 over the square root of x. Next, we differentiate the fx. And after differentiate it, the answer we will get is 1 over 4 divided by the fourth root of x cubed plus 1 over the square root of x cubed. The x given is 15.98 and the x chosen is 16. After subtract the x given and x chosen, we will have negative 0.02. Lastly, apply all the information we get into the formula given. Then we will have our final answer, which is 1.499. For the conclusion, this question does apply a linear approximation formula.